All right, so let's see. Share this. Okay. Problem 4.65. So it says find the Norton equivalent with respect to the two terminals, A and B. So I'm going to go ahead and find the V open circuit, which is the same as the voltage across this 3K ohm component, right? So yeah, I'm going to go ahead and use mesh analysis. So we have two loops, right? I'm going to call loop one. Well, we have two equations, sorry, not two loops. We know that with the first equation, we're going to call I1 equal 75 milliamp, or 75 over 1,000. And then our second equation is going to be, I'm going to call this I2, right? So we have 4,000 times I2 minus I1 plus 2,000 times I2 plus 3,000 times I2 equals 0. Right, so I'm gonna go ahead and plug this into Maximo just because I want to avoid doing all the math. Let's do that. So I1 equals 75 over 1,000, and then 4,000 times I2 minus I1 plus 2,000 times I2 plus 3,000 times I2 equals 0. We want I1 and I2. So just to confirm that I1 is 75 milliamps over 40 is 0.075 milliamps, and then I2 is 1 over 30, right? So go ahead. Maxima says I2 is equal to 1 over 30. Right? Okay, so with I2, we were able to find what the open circuit is, right? We know Ohm's law, V equals I times R, and we know for the open circuit, it's I2 times R. So 1 over 30 over 3,000, easy, 100 volts, the open circuit. So I'm gonna redraw this, or I'm gonna just copy and paste the same image. So let me go back to this. Right. So I'm gonna, yeah, let's do that. So here now I'm gonna find my I short circuit, right? So I'm gonna connect these, and I'm gonna do this. I'm gonna make 3 loops this time. So I'm gonna have a same one, I1, I2, and then I'm gonna call this ISC, I short circuit. So this time, essentially what this does, we know that the current follows the path of least resistance. So therefore, our 3K ohm is basically canceled out. So you just have, this would not be a thing. This is, yeah, and then we just pretend it goes like this. I'm gonna redraw this. I'm gonna make this I'm gonna make this our this is what our circuit would look like now. So we have 2K, 4K, 5 milliamp. So yeah, we wouldn't have 3 loops. Sorry. So we still have we have 1 loop. We have 2 equations. That's my avoid what I said with the loops earlier. 2 equations, 1 loop. So our 1 loop would be this. You could say, well, I'm going to call that I1 again, and then I'm going to call this I short circuit, right? The wording is like the most, the way you want to communicate this, it's my bad. You want to be accurate with the way you say things, because if not, that can cause confusion. I need to be more like that. Anyways, so no, not I short circuit. Okay, yeah. So then we have 4,000 I short circuit minus I1 plus 2,000 ISC equals 0. So just to avoid the math, I'm going to plug this into Maxim again. All right, 2 equations. I1 equals 75 over 1,000. 1,000 times ISC minus 1 plus 1,000 times ISC equals 0. ISC and I1. Okay, so you get this. So our ISC, short circuit, what was it again? 1 over 20. So 1 over 20, right? So essentially what our V open circuit would be is our V Thevenin, and our I short circuit would be our I Norton. So since we want the Norton equivalent, we have the values now to either make a Norton or a Thevenin equivalent. With these values, now we're able to find R Norton, which is also R Thevenin, same. So by Ohm's law, right, you know, V equals IR. So R is equal to V over I. So we can say 100 times 1 over 20, right? So 100 times 20, 2,000 ohms. So our equivalent our I Norton equivalent would look like this. So we have current source, it's going to be 1 over 20 amps. And this is our Norton equivalent.